A polynomial equation is an equation where the x's are raised to positive integer powers. So in an equation of one variable, if the powers of x's are elements of the integers that are positive, then we have a polynomial. Some terms that are not allowed in a polynomial equation would be anything with an x in the denominator, anything with an x under the radical, anything with a fractional exponent, and anything with a negative exponent. None of these terms are allowed in a polynomial equation. There are a couple of characteristics that we need to mention for polynomial equations in general, which is that polynomials will have the same number of solutions as the degree. The degree of a polynomial is determined by the highest power on the x whenever that polynomial is in its completely multiplied out phase. So in this case, the degree of the polynomial is 3, which means that we're expecting to find 3 solutions to this equation. Another characteristic of polynomials is that they do not generate extraneous solutions. So when we come up with these 3 solutions at the end, we can expect that all 3 of them will work and none of them will be extraneous. So now that we've identified this as being a polynomial, we're going to demonstrate how to set that equal to 0 and then factor the polynomial in order to solve this equation for x. So our first step is to set it equal to 0, so we'll subtract x and subtract 4 from both sides. On the right, these terms cancel out, and on the left, there are no common terms, so we're just going to copy-paste each of the terms down, and we write this in descending order, which is standard. Now, we have a 4-term polynomial on the left-hand side, and we're going to factor this polynomial by the grouping method. So we'll group the first 2 terms together and the second 2 terms together, noticing that in the first 2 terms we have a common factor of x squared. So when we factor the x squared out of this first term, we end up with just an x that remains. When we factor the x squared out of this second term, we end up with a plus 4 that remains. And that completes our first group. Now we're going to look at the second group, and we'll need to factor out a negative 1 to ensure that what remains is going to be the same binomial that was generated from the first grouping. So we'll factor a negative 1 out of the first term to get a positive x that remains, and a negative 1 out of the second term to get a positive 4 that remains, and we're still equal to 0 on the other side. So now we have 2 larger quantities here where each of them contains a factor of x plus 4. So x plus 4 is a common factor to both of these, and therefore we will factor it out. When we take the x plus 4 out of this first quantity, we have the x squared that remains. And when we take the x plus 4 out of this quantity, we have the minus 1 that remains. And so now we have the product of these 2 factors. So while this is factored, it's not completely factored because x squared minus 1 will factor more. X squared minus 1 is the difference of squares, and our formula for factoring the difference of 2 things that have square roots is going to be x plus y times x minus y, which is essentially the square root of the first term plus the square root of the second term times the square root of the first term minus the square root of the second term. So we copy-paste the x plus 4. That quantity does not factor any farther, and we'll factor x squared minus 1 using the difference of squares formula to be x plus 1 times x minus 1, and we're still equal to 0. Now that our polynomial is completely factored, we're going to take each of these factors and set them individually to 0. So x plus 4 is equal to 0, x plus 1 is equal to 0, and x minus 1 is equal to 0. We solve each of these individually. To get 3 solutions, x is equal to negative 4, x is equal to negative 1, and x is equal to positive 1. And all 3 of these solutions do work back in the original equation.